Last section of our proofs chapter. Whoop, whoop.
Whoop, whoop.
Exactly. That was good. We have overlapping triangles. As you can tell, there's like craziness going on in all of these. So what we have today, thanks, John. What we have is a bunch of stuff that is shared between the triangles. So we're gonna have lots of reflexive in this section. Yeah. So if I look at triangle in this one, it says ABD. So that's triangle ABD. And triangle DCA. What do they have in common?
They're flipped.
Which one?
Or no, the intercept.
They cross. Yeah, they cross right here. But do they have like an entire line that's shared? Which one? Yeah, this bottom dude. This bottom dude is both blue and green. So they share AD. So like when we start to do our proofs, we're going to use the fact that they share that, and we're going to do our reflexive, and that's going to get us a side that's the same. Something that is kind of confusing about this section is if I look at this like angle right here, it's that tiny angle's in the green triangle, and it's also in the blue triangle, but it's not all of that angle in the blue triangle. Because the blue one is like this right angle, but the green one's only this little angle. So we don't say that they share that one because they're not sharing the whole thing. So in order to be in common, they have to share the whole thing. Like they share this whole line down here, but like here they cross, but they're not sharing any of like this line or this line. They're not sharing that. So you have to share the whole thing in order for it to be common. Okay? This might be kind of challenging for like visually until you get used to it a little bit. So don't worry about that. We'll do lots of examples. Alright. Here, I like to separate the triangles just so that I can see like what the overlapping stuff is. If I have triangle BEC, that's that dude right there. If I separate that out, it's going to look something like this. And let's label it B, E, C. And then I have a triangle BDF, BDF, and that looks like kind of almost the opposite, where B's here, D's here, and F is here. Alright, so we got our separated triangles. Now what the separated triangles are supposed to help with is where there's just like a little part overlapping and where a whole thing is overlapping. So if I look here, do you notice how both like from B to F is blue and green? Does everybody see that? Okay, but since the blue triangle doesn't stop at F, it goes all the way to E, we don't say that that's a common part because it's only sharing just this little bit, not the whole side. Does that make sense?
Well, what the frick, why not?
Because we want to look at the whole thing. It's got to share the whole thing. So like here we got BE, but here we only have BF. So those aren't the same letters total.
Yeah.
So we don't say that they like, that's on a whole part that's in common. Okay? And we only care about like the whole part. However, what they do have in common is this thing up at the top. Wouldn't you say that this angle B, no matter which one you're looking at, is the same angle? Yeah, does everybody see how they share that whole angle B? Like the whole part of it? Because whether you're looking at, let's see over here. Whether you're looking at FBC, or FBD, sorry, or CBE, that's the same measure, okay? I mean, we don't know what it is, but we know that it's the same because they're sharing that whole part of that angle. So what they have in common is angle B. they have that whole angle in common. They don't have any sides in common. They have parts of sides, like we talked about, but they don't have any whole sides in common. Just that whole angle at the top. Alright, if I look at this one, I got GLJ. So let's draw that one, GLJ. And then I have HJL. That looks like that. HJL. I always feel like sides are like easier to tell what they share. Are there any sides in this one that they share completely? LJ, yeah. You'll notice that we have LJ here and LJ here. And on this guy, they're both blue and green, so LJ is what they share. You also notice that this angle L, they do not share. Because angle L here, like if I had to guess, I'd say like 90, is different than this angle L here. So they do not share angle L because they don't share the whole thing. It's not the same measure in each triangle. Does that make sense how they don't share that? Okay. Alright. I think the most confusing part about this section is like trying to figure out what they share, and then the proofs are okay. Alright, let's do this one. When you do these overlapping triangles, it's super important. I like to look at what the proof part is, because that'll tell you what triangle to pull out of your picture. Because here we got like 12 different triangles going on, but the ones we want to focus on are BEC. So let's draw that one, BEC. So I'm going to draw it over here, BEC. And the other one we have is BDF. Alright. First thing always in proofs is my what? The given stuff. So let's write that down. I got BF is congruent to BC. That is given. And angle BEC is congruent to angle BDF. That is given. Alright. Now, the reason we separate these triangles and like redraw them is because if I started putting dashes on this overlapping one, you have like no idea what's going on. It just looks like a disaster. So that's why we separate them. So we got to mark that BF is congruent to BC. So BF, BC, those are congruent. And then we also have that angle BEC, that's that dude, is congruent to BDF, that dude. So far we have a side and an angle. And how many things do I need to make triangles congruent? I need 3, so I'm only missing 1. Well, that missing one, we're out of my given, is the overlapping part. Who can tell what they share? Go.
Angle B.
Yeah, they share this angle B. This angle B is shared completely. So what we're going to do is we're going to go angle B is congruent to angle B. And who knows what reason I'd use? Reflexive, yeah. Anytime they share something, you're going to write reflexive. And then make sure you mark it in your triangle. So the overlapping one, like the picture that you're given, that's what I would use to figure out what they share. But then to figure out why my triangles are congruent, I would use like the broken up ones so you can tell better what's all marked. So can I do the proof part now? Yep. I have triangle BEC is congruent to triangle BDF because I have what going on? My option side, 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 angle, and HL. Which one? Angle, angle, side. Angle, angle, side. Angle, angle, side. What?
That was hard.
You don't like it? Or Mr. Faster like it on your mouth?
I'm not as
Uh-oh. Alright, let's flip to the back. You'll notice this time, I'm not trying to prove triangles are congruent, I'm trying to prove what? My sides. I'm looking at AC and BD. Those are the sides I want to be congruent. In order for sides to be congruent, what do I first have to prove? Think back to Monday. Yeah, I'm going to use CP-CTC, which means I have to first prove that my triangles are congruent. Okay, so the triangles we're going to look at is this triangle. So I have ACD. And then I got this triangle, BDC. Yeah. Alright, what's the first thing I'm putting? I given AD is congruent to BC, and angle ADC is congruent to angle BCD. Both of those are given. And then make sure you put them in your triangles that are separated, ADBC, and then angle ADBC and BCD. What else? I'm out of my given, right?
Yeah.
So I gotta look at my picture. Another overlapping triangle, so they gotta share something. They have to share something.
CD.
CD, they share this dude. This line, CD. They share that.
And then you
So
gotta
what should I write? Uh-huh.
You gotta put reflective.
And then reflexive, good. And then mark it on your picture. Do I have three things? Yeah, so now I can say my triangles are congruent. So we'll go triangle ADC is congruent to triangle BCD. And why are they congruent? Side angle side. Good. Your angle is in between the two sides you're given. Now, can I do my proof part? Yep, since my triangles are congruent, I can do the proof. AC is congruent to BD. Because of why? There you go, CP-CTC.
CTE.
Alright. Questions there? Okay, we got one more. I want it clear. There we go. Alright. We got sides again that I want to prove are congruent. I have this dude BD that I want to prove is congruent to this dude FD. Ooh, so it's kind of tricky. It's kind of hard to see which which triangles they might be talking about. So let's look at what the angles were given. If I'm looking at angle CAD, looking at that angle, and then I'm looking at EAD, looking at that angle, and then I have this angle C and this angle E, which triangles do you think we might want to use?
This looks like a bird's eye view of Hickory Point.
It does. It does.
Where would the bird?
Do they do they share anything? They share AD. So maybe we'll look at these triangles. That's what you were talking about, right? What you meant by the red ones? Yeah. Yeah. Okay. All right. So let's break off and do CDA, and we'll do this one. E D A. As always, start with your given. Angle CAD is congruent to angle EAD. It is given. And angle C is congruent to angle E. That is given. Mark them in your picture, CAD, EAD, and then angle C and angle E. Good there?
Yes.
Then what did we say they shared? They share AD, so I'm going to write AD as congruent to what? AD, Y, reflexive. Mark it. Now what? Yeah, I have three things, so I can say the triangles are congruent. Triangle CAD is congruent to triangle EAD. Because why? Which one is it?
What if I said angle side?
No, angle sides. No. Let's start here. What do I got going on here?
Okay.
Angle. Nothing going on this way, so I gotta go this way. Then I have a
What did I say?
angle.
What
side.
did I say?
Well, no one said it real confidently.
I said it.
Angle side.
Thanks, bud.
Good job, Dylan Severson.
What?
Alright. Question. Is this BD and DF, are they in my triangles? Like, are they a part of my triangles, or are they just like inside the triangles? They're just inside it. Yeah, they're just hanging out. They're not a part of these red triangles.
Yeah.
So we got a little bit more to do. I can't say right away that BD and FD are congruent because they aren't even a part, they're not a side of these triangles that we have marked.
Do we have to make our own other triangle?
We're gonna make another triangle.
Why didn't we just do that to start with?
We're gonna do it this way, promise. I didn't just do stuff to do stuff.
Because we were given
Promise.
something.
Sounds like.
Yeah, we were given different stuff. Alright, so the first thing I want to say, I'll lead you guys to this. Can I now that my triangles are congruent say that CD and DE
Yes.
are congruent?
Yes.
Yeah, I can say that. CD is congruent to DE. And after saying my triangles are congruent, why could I say that?
Because they're part of your system.
There you go. CPCTC.
Okay.
Alright, you guys all have room over here, right? I want you to draw this little, what's called hourglass. There we go.
Ooh, hourglass, and I already missed it.
And then C, B, D.
Oh, I lied.
Okay, and we already have, this is stuff that we were already given, we already know C and E are the same. We now said that CD and ED are the same. What else do I have going on in this picture? Yes, ma'am, I got vertical angles. So I'm going to say angle BDC is congruent to angle FDE because they are vertical angles. Can I now say that those triangles are the same? I sure can. I can say triangle BDC is congruent to triangle FDE because of what's going on in these black triangles. Angle, side angle. And now, finally, now that the triangles are congruent, can I say that BD and FD are congruent? Yep. BD is congruent to FD because, oh, I didn't know it was a triangle. Sorry. Triangle. Why can I say that? There you go. CPCTC. Great news. You'll never have to do one like that again.
Great.
Woohoo!